Good afternoon, everybody. I'm delighted to be joined by Mathilda Thompson from Deliveroo, who are one of our amazing Athena sponsors. I'm going to be going through, as you can see, a brief introduction to how the internet works. I think before I hand over to Mathilda, just kind of to say that if there are any questions throughout the session, let us know in the chat. I'll make sure that I get them filtered through to Mathilda. We'll have kind of Q&A time at the end as well. So feel free to kind of ask throughout and we'll make sure they get answered. I think just a quick note as well, before fully handing over, I'll stop speaking and let you get to it. We can, on the Showcode platform, for those earlier on the session, you can join and follow Deliveroo's hub on our Showcode platform. That will kind of give you some latest updates. It will give you kind of like exclusive access to some of the core content that they'll be doing on the platform. So I'll put the link to the chat. I'll put the link to that in the chat now. So feel free to join throughout this session. But without further ado, I'll stop mumbling and pass over to Mathilda.
Hi, I'm Mathilda. Nice to meet you all. So yeah, I'm a software engineer at Deliveroo. I didn't study computer science at uni. I studied biology and chemistry, and then after I graduated, I took a coding bootcamp course, which was quite a long time ago now, I think in 2013. And then after I finished that, I worked at ThoughtWorks, and I've been at Deliveroo for about 6 years now. In Deliveroo, I've worked across different parts of the business. So I started out in the growth team and worked on products such as Deliveroo Plus, which is our subscription service. And now I've moved to the grocery group because we've kind of scaled out in the grocery space, and we're trying to work on scaling out our menus. So yeah, that's a bit about me. And today I'm going to talk about a brief introduction to how the internet works. So what we're gonna cover what the internet is, and then we're going to also have a look at what happens on the internet when you place an order on Deliveroo or any other e-commerce website. So let's take a step back and look at a brief history of the internet. So the catalyst in the formation of the internet was the heating up of the Cold War in the 1960s. So the Soviet Union's launch of the Sputnik satellite spurred the US Defense Department to consider ways information could still be disseminated even after a nuclear attack. So in 1969, this eventually led to the formation of the Advanced Research Project Agency network, the network that ultimately evolved to what we know as the internet today. And the system they built is pretty largely unchanged. I think it's amazing to think that the people that invented it had the foresight to design something that could scale indefinitely and change the way the world communicates. So as we all know, the internet has revolutionized the way we live by enabling near instant digital communication. So today there are a large number of billion-dollar companies such as social media platforms, Instagram, Facebook, e-commerce stores such as Amazon and Deliveroo, dating apps such as Tinder, and many more. And all of these businesses have been built on top of the internet. But what is the internet? So the internet is a decentralized system composed of many networks that can communicate directly and indirectly with each other. So you can think of the internet as a very, very fast version of the postal service. And hopefully that will become clear as we go through the presentation. So we just discussed that the internet was this, network of networks. But what is a network? So a good example of a network is your home internet setup. I imagine most of you have several devices or nodes. You can kind of use those words interchangeably, such as your phone, your laptop, your TV, connected either via Wi-Fi or an Ethernet cable to a router that was provided by your internet service provider. So the router serves as a gateway to the outside world and directs data across the internet. The router also assigns a unique internet protocol, which is often shortened to IP, and you might have heard of that address, which is a set of 9 to 12 numbers to each of the devices connected to the network. And you can see on the slides on the left-hand side, each device has got their own unique IP. So this network setup confined to a small geographical area is known as a local area network. And then local area networks can be connected up together are called wide area networks, which is often shortened to WAN. And wide area networks span over wide geographical areas and are composed of multiple local area networks. And all of the wide area networks connected together are known as the internet. So networks across the globe are connected together by cables, copper cables or fiber optic cables. And when I found this image, it kind of blew my mind a bit. And these subsea cables are the invisible force driving today's internet. So when you're watching your favorite program on Netflix, infinite amounts of data are traveling across the bottom of the ocean. And today's subsea market is booming. I think there's around 400 cables in service around the world, spanning over 1.2 million kilometers. And you may have read in the news recently that Putin has been threatening to cut some of these subsea cables, which could be seen as a war crime because it would cause huge disruption to crucial communication systems across the globe. And this is what a subsea fiber optic cable looks like. So the cable contains strands of plastic or glass fiber that transmit information using light. So light bounces through the inside of the cables, carrying the network signal with it. And networks can also be connected together via satellite. So satellites work by sending and receiving data using radio waves. So when you think of the billionaire Elon Musk, you might think of Tesla or about the fact he recently purchased Twitter. Something you might be less familiar with is Starlink, and it's a venture that aims to bring the other 3 billion people online. And these 3 billion people currently don't have access to the internet because they're living in remote rural locations that are not physically connected to the cable. So to get these 3 billion people online, Musk is launching thousands of broadband satellites into low Earth orbit across the globe. And so satellites are normally, I think, at a higher Earth orbit of around 22,000 miles away from Earth. But these Starlink satellites are only 330 miles away. I think, they're quite easy to see. And this low orbit is going to significantly increase the internet speed. So I think Starlink satellites currently advertise it will take 20 milliseconds to load a page, and fiber optic cables currently take 17 milliseconds. So it's only currently a tiny bit slower than fiber optic, and they're hoping to speed it up even more. And you might have recently read that Elon Musk has deployed a bunch of these Starlink satellites above the Ukraine to keep the residents online, as Russian bombing has destroyed some of the physical cables and telecommunication systems, which has taken the internet down in parts of the Ukraine. So now we've kind of briefly discussed, what the physical internet is. Let's have a look at how the internet works. So imagine you're in your flat in Edinburgh, it's a cold evening, you're feeling hungry, and you decide that you want to order a cheeseburger, some fries, and Coke from Deliveroo's website on your laptop. So have you ever thought about what actually happens behind the scenes when you click that place order button? So remember we discussed previously when we were looking at local area networks that every device on a network has an IP address, a unique IP address to identify itself on the network. So when you place your Deliveroo order, you can see on the slide in the URL you typed deliveroo.co.uk from your browser, and you're saying that you want this order data to be sent to deliveroo.co.uk. But the internet doesn't understand domain names. It only understands IP addresses. So the reason domain names exist is because it's much easier for humans to remember text as opposed to numbers. Imagine every time you had to visit a website, you had to remember, a 9-digit number. It might be quite hard to visit websites. So this means that the first thing that needs to happen is the domain name needs to be translated into an IP address. And this is called domain name resolution. And you can compare it to looking up a phone number in the yellow pages. So to convert a domain name into an IP address, the browser sends a request to a recursive resolver DNS server. This server then sends off subsequent requests to other DNS servers, you can see on the right-hand side of the slide, in a hierarchical structure until one of them returns the IP address that maps to the deliveroo.co.uk domain. So this is a really complex process. And at the end, I can link some resources that you might find useful to read more about it. But I think the simplest thing to try and kind of tell the story without getting in too much depth is to compare it to an analogy of this. So you can think of the recursive resolver as someone who wants to rent the book 101 Fabulous Things to Do in Rome from the library, and they need the book's reference number, which is on the spine of the book, to rent it. So the first thing they do is they ask the librarian on the ground floor, which is equivalent to the first DNS server, where the travel section in the library is. And the librarian replies that it's at the back on the left-hand side next to the stairs. So next they ask the librarian in the travel section, which is equivalent to the second DNS server, where the European travel section is. And they reply, in the bottom of shelf 12. Then they ask the next librarian in the European travel section, which is equivalent to the third DNS server, to find the book on shelf 10 called 101 Fabulous Things to Do in Rome. And they read up the reference number on the side of the book, which means now the person has got the reference number so they can rent the book. So you can see in the diagram here, the main thing to take away is that the deliveroo.co.uk domain is sent to a bunch of DNS servers, and it's translated into the IP address 172.64.1542. So you might remember in October last year where Meta's Facebook, Instagram, and WhatsApp were all unavailable for most of the evening, which disrupted communication for billions of users. And this was because a configuration issue meant their DNS servers went offline. So when you tried to visit facebook.com on your laptop, the domain name couldn't be converted into an IP address. So your laptop had no idea where to go to contact Facebook's servers. There's a useful tool you can use called dig, and you can type it into the command line to perform DNS lookups and resolve domain names into IP. You can see here, I've done it for bbc.co.uk, and you can see that it's got a bunch of different IPs. And you can see that deliveroo.co.uk has got 2 different IPs. And this is because we serve our content from different geographical locations for reliability reasons. So now the domain name has been resolved to the IP. So we know the destination of Deliveroo servers. You can see on the right-hand side, Deliveroo servers are at 172.64.1542. So the internet, we know where to go on the internet. The next thing that needs to happen is for your data to be packaged up into a packet to be sent over the network. And you can compare this to sending an item in the post. So you write a letter, which is equivalent to the data that you want to send, which in this case is your Deliveroo order data. You write the recipient's address in the letter, which is equivalent to Deliveroo server's IP address. And you write the sender's address on the letter, which is equivalent to the IP address of the device you place the order with. And when you send a packet in the mail, you often choose a certain kind of service. So you could choose like recorded delivery or sign for, depending on the importance of the packet. And the same applies to sending packets across the internet. So in this case, it's very important that the order is sent from your laptop in Edinburgh to Deliveroo servers in Ireland, and that it doesn't get lost en route. So we will choose a service, and on the web it's known as a protocol called Transmission Control Protocol, which is used to ensure reliable transmission of packets. Another protocol that's commonly used to communicate on the internet, and it will be actually being used on this call, you might have heard of it, is called User Datagram Protocol, UDP. And that's used in time-sensitive applications such as real-time video and audio conferencing because it's very fast, but it does not ensure reliable transmission of packets across the network. Because if a packet is dropped en route to its destination, there's no point resending it because an out-of-date audio packet is not useful. And a drop packet on a video call looks like a blip in the video call. So now we know we've resolved the domain to the IP, we've packeted up the data. But how does the packet travel in a number of milliseconds from your laptop in Edinburgh to Deliveroo servers in Ireland? How does it know which way to go? When we want to travel to a destination these days, we let Google Maps tell us which way to go. But how do the packets know which networks to traverse through to get to their destination? So packets know which way to go thanks to the Internet Protocol. So protocol stands for a set of rules, and this is a set of routing rules. So internet routing decisions are made by special pieces of hardware called routers. We discussed routers at the start of the presentation. Remember, routers connect networks together. So when a packet is traveling across networks, routers will give the packet routing instructions about which network it should go to next to find its destination. So for example, for the data packet to get from your laptop in Edinburgh to get to Deliveroo servers in Ireland, should it pass through networks 1, 3, and 5, or networks 2 and 4? The packet will take a shorter path through networks 2, 4, and 5, but networks 2 and 4, but networks 1, 3, and 5 might be faster at forwarding packets than 2 and 4. And these are the kind of choices network routers are constantly making. So this means that packets moving between different hosts, so your laptop and Deliveroo servers, will often travel via different networks. And this is similar to Google Maps or Waze. So depending on the time of day and the congestion on certain roads, it will route you on different paths. So there's a useful tool that you can use called Traceroute, which helps you to view the different networks that a packet passes through to get from its source, so your laptop in Edinburgh, to Deliveroo servers in this case. So you can see here, 192.168.1.1 is the IP of my network that my laptop's on. Then it passes through the internet service provider, which is controller.zippynet.co.uk. Then it looks like it travels through London at hops 6 and 7. And then hop 10 is Deliveroo's server IP in Ireland. So you can see it's traversed through 10 networks, and they're known as hops to get from the source to the destination. So what happens once the packet has arrived at Deliveroo's servers? So because we are using this reliable TCP protocol, the first thing we need to do is we need to send an acknowledgement packet back to the host, so the laptop in Edinburgh, to let it know that we've received the packet. Then the packet will be unbundled and processed, and a new order will be created in Deliveroo's database. So in summary, we can see, step 1 was DNS resolution, was the domain was translated to an IP. Step 2 was, building a packet, and the packet was built using the TCP protocol to ensure that it was delivered reliably. Step 3 was routing the packet across the network. And step 4 was the arrival of the packet, sending the acknowledgement packet back to the host, and the unbundling and processing of the packet to create the order in Deliveroo's database. So in conclusion, we see that the internet is a network of networks. It's easy to think of it as this invisible thing, but it's everywhere from subsea cables to satellite dishes on houses to a constellation of satellites in the atmosphere. And I hope you're now a little bit clearer about what happens when you place an order on an e-commerce site. It's not magic. It's actually, moving packets through networks on the internet, which is very similar to the postal service, just much, much faster. So yeah, that's the end. Thanks very much for listening. Yeah, and here are some resources and contact details, and yeah, feel free to go with any questions.
Thank you very much. I always forget just how much I learn when we have these Athena webinars, and I think I know for a fact that if I had to try and remember a 9-digit number every time I was searching for the internet, I would order much less Deliveroo and have much less success. So yeah, super interesting. I think, does anyone kind of have any questions, whether that's for Mathilda, whether it's about the session, whether it's just generically, like I say, let us know in the chat. Make sure to get them asked. I think I'll kind of kick things off with just a generic one to start with around, is there any kind of tips that you would give to the hackers for this weekend? So just in the sense that obviously a lot of people, I think it's their first time sort of at a hackathon in potentially a group environment. And I guess past that as well, from a career perspective, as you said, I think your career path has been a really interesting one to get to the point that you're at now. So I guess some kind of general advice, if you have any, whether it's hackathon, career, or whatever, would be great. And I'll wait for some questions to filter in the chat.
Cool. Do a hackathon. I don't know if I think, yeah, just kind of have fun mainly. And also, whatever you build this weekend, you can also continue working on it, and you can definitely use it in job interviews. People are super interested in what you've been working on kind of outside day to day, kind of showing you have that passion to work on like pet projects and stuff. So
I think that's great. I was going to say, I think that's good advice. I didn't mean to throw you too much under the bus with that one, but I think that is great advice. And have fun's always a good one. We've had a question in the chat from Escher about how does the package route physically over the network? So do you have an example of that, or do you have any information on kind of how that works?
So kind of it routes physically over the network, like via, in the fiber optic cables, via this light that transmits the signal. If that kind of makes it, if that answers your question, it's very complicated. Yeah. And via satellite that uses radio waves to transmit the signals.
I was going to say, I feel like we could be here for an entire afternoon to go into the physicalities of the internet. But no, I think that's a good question. And I think it's interesting actually how much more this can probably provoke in terms of, wider research, wider kind of, looking into it. Because like you say, there's a whole host of things out there. And I think we'll make sure that we get these resources sent out on Discord as well, so that you have them. I think they'll probably be super useful as well. And if there are any kind of further questions after this, hopefully that does a good job of answering those.
Yeah, like feel free to email me with any questions you've got as well.
There you go. I think for now that seems to be it from a chat question perspective. We always have retrospectively, and obviously now that you've got details, hopefully you can email Mathilda in the team as well. So that's all good. I think thank you very much for listening. And Mathilda, massive thank you for coming along and doing this. I think, like I say, every day is a school day for me when we come around to doing Athena sessions. So really appreciate it, and really kind of appreciate your time. So thank you very much for getting involved. One final note from me is just make sure that you give the Deliveroo Hub a follow. That link should be in the chat. So I think if you just give them a follow, then we'll have kind of more webinars in the future, more projects, more hacks and stuff like that. So that'd be great. And yeah, thank you very much, everyone.
Yeah, thanks for having me, and enjoy the hackathon.
Cheers. Bye bye.
Cool, bye.